Hi guys, we're going to work on Unit 9, Lesson 4, the law of cosines. And a couple things about the law of cosines is it is located in your reference sheet, so if you ever don't know what it is, make sure you look back at your reference sheet. And the only thing about the law of cosines is we want to make sure that these two values are always the same. So we always want it to be the side opposite the angle in the equation here. So again, you can manipulate A, B, and C however you want. Just make sure that the side that you want to solve for or that you have and the opposite angle are a pair there. All right, let's get into this. It says if the measure of angle C equals 90 degrees, then the first form of the law of cosines results in what famous theorem? Justify your answer by substituting 90 degrees for C. So we're going to go ahead and use C squared equals A squared plus B squared minus 2AB cosine. But this time we're going to substitute in 90 degrees. And if you remember, the cosine of 90 has a value of 0. So we're going to have C squared equals A squared plus B squared. Well, minus 2AB times 0 is just going to be 0. So if you remember, this is the good old Pythagorean theorem. So let's go ahead and jump in and start solving some of these. What I like to do is, here's my angle. So that means that since this is across from angle B, this is going to be little b. This side across from angle A, this is going to be my little a value. This side across from angle C is going to be little c. So since I have angle B and side B that I'm solving for, I'm going to want to use B squared equals A squared plus C squared minus 2AC cosine of B. All right, so I don't have my B value. A squared is going to be 13 squared plus my value for C. I'm just going to go ahead and substitute in here. Okay. And the nice thing about this one is on the right-hand side of this equation, there are no variables, so I can go ahead and use my graphing calculator and put all those values in. So if you do that, let's see, we have 13 squared plus 8 squared minus 2 times 13, 8 cosine 110. And you want to make sure that your calculator is in degree mode. So let's just make sure that I am in degree. Oh, and see I am in radian mode here. And hit enter. Well, let's see. So I should get this value. So I'm going to come back here, B squared 304.14018898. In order to undo that square, I got to take the square root of both sides. And if I read, it says to the nearest tenth. So I'm going to go ahead and round that to 17.4. In triangle DEF below, DE equals 11, EF equals 15, DF equals 20. Determine the measure of D to the nearest degree. So this is what I want. And if you're more comfortable, you can rename these temporarily. So I went ahead and I called this my A, this is my B, this is my C. So that means that the side across from angle A, this would be little a. The side across from angle B, this would be little b. And we're going to solve for angle C. So in my equation, I want to make sure I start with the C squared equals A squared plus B squared minus 2AB cosine of C. So I'm going to substitute in here 15 squared, 20 squared, 11 squared, 2 times 20. And hopefully you notice this time that here's the missing part. So it's going to be a little bit more challenging to solve, but it's okay. So we're going to go ahead and evaluate 15 squared, and we get 225. And now we're going to have to follow some order of operation rules. I'm going to take care of this first because these guys are being added. So 20 squared plus 11 squared is 521. minus, so now I'm going to go ahead and take care of these guys. 2 times 20 times 11 is 440. Just going to get rid of those. And then I have the cosine of C. And again, that's what I'm solving for, is the cosine of C. So, in order to solve this, 521. And we get negative 296. This cancels. Negative 440. Cosine of C. Divide again by negative 440. And you would get 0.672 equals the cosine of C. So again, go back and read. It says to the nearest degree. Well, this doesn't look like a degree measurement. And again, C isn't all by itself. So if you remember, in your graphing calculator, you're going to hit the second key and then the cosine key to turn that 0.672 into a degree measurement. So I get 47.778, blah, blah, blah. So they wanted it to the nearest degree. So 47.7 actually rounds up to 48 degrees. And we're going to go ahead and write, so the measurement of angle D, because that's what they asked us to solve for, is 48 degrees. In this one, they want us to find the measure of the largest angle of this triangle to the nearest tenth of a degree. All right, so I have a triangle. And it has 3 sides that measure 8, 14, and 20. And they want us to find the largest angle. Well, if you remember, the largest angle is across from the largest side, so that's going to be up here. So I'm going to go ahead and label my triangle. So that means that the 20 is little c, this is going to be little a, little b. So I'm going to write my formula. I'm going to substitute in, let's see, I have little c, 20 squared, I have a, and again, I am missing the cosine value. Let's see here. Oops, I don't want to do it that way. I'll do it in yellow. Okay, so 20 squared is 400, and I'm going to take care of the 8 squared plus 14 squared again in one step. I'm going to take care of the 2 times 8 times 14 in one step. I'm going to bring the 260 to the other side. So I would get 140. Oops. Minus 260. 140 down here. You're going to divide both sides by negative 224. And you would get, sorry about that, ran out of room, negative 0.625 equals the cosine of C. And again, we're not looking for the cosine of C, we just want C. So I go to my calculator, second cosine of negative 0.625, close it. And I get 128.68 degrees. And how did they want me to round this? They wanted me to round this to the nearest tenth of a degree. So I'm going to go ahead and say it's 128.7. All right. Using your answer from part A, determine the area of this triangle to the nearest square centimeter. So maybe we haven't discussed this explicitly yet, but the formula for the area of a triangle can also be found on your reference sheet. And it's this one. Okay, so I'm not sure why they use K, but we're going to go with it. So 1/2, the value of A was 8. The value of B was 14, and we're going to take the sine of the angle, which was 128.7. When you just substitute that all in your calculator, right, because there's no variables on that side, you get 43.7, and they want it to the nearest square centimeter, so the area of the triangle is 40, we're going to go 44 centimeters squared. Okay. Exercise 5. Oh goodness. A satellite dish can track the speed of a plane by recording the distance to the plane at 2 points in time and the angle through which the dish rotates. In the picture below, a satellite measured the distance to a jet at 35 miles. After 0.25 hours, 15 minutes, it measured the distance to the jet at 58 miles. If the satellite rotated through an angle that measured 132 degrees, determine the average speed of the plane to the nearest mile per hour. All right, so let's talk about miles per hour. I need a miles in the numerator and an hour value in the denominator. Well, I have to figure out how many miles they traveled. So again, I have a triangle, right? I have 132 degrees down here. This side is going to be 58. This side is obviously going to be 35. And I'm looking for this value right here. And actually, I'm not going to use X. I'm going to use C. So this is big C, angle A, B, this is little b, little a. So let's write our equation. C squared equals A squared plus B squared minus 2AB cosine of C. I don't know what C is. I know that A is 35 squared plus 38 squared minus 2 times 35 is 38. Cosine of the angle, which we know is 132. This one's actually nice because I can substitute all that or throw that right in my calculator. There's no variables on that side, and I get this very large number. I take the square root of both sides to get rid of that square. I get 85.473. All right, so let's go back to that question. Determine the average speed of the plane. Well, now I know my distance. I went 85.473 miles. But how long did it take me to go that 85.473 miles? Well, it told us in the question right here. So the average speed is going to be my miles per my hours, and if you look, it said 0.25, right? I don't want to use this one because that's minutes, so I'm going to use the hours one because I want miles per hour. And if you divide those, you get 341.892. And the question said to the nearest mile per hour. So this to the nearest mile per hour would be 342 miles per hour. All right, well, thanks for tuning in. And just remember that today's topic was about the law of cosines. So let's go back up to our law of cosines. And you can also find this in your reference sheet. And just the key thing is you can always relabel your triangle so it's more comfortable for you. But the main thing is that you want the side and the angle it's paired up with on the ends. And then you can kind of figure out the middle part. All right, guys, have a great night.